Part D is exactly the same as Part C, except for now we have 30 milliliters of NaOH. Again, I'm going to first do it the easy way, then I'm going to go ahead and do it the difficult way. That way, if the easy way didn't make sense for you, you can follow through. I shouldn't say the difficult way, the long way would be better. Now, I'm going to remember from my last problems, because my volume and my molarity of nitrous acid does not change every time. So I know that I'm going to start out with 0.050 moles of HNO3. What's different this time is I'm adding 30 milliliters of NaOH. Now, realistically, in a titration, I added 15 milliliters more. But, as we've said 100 times up until now, if we do that, if we try and look at it that way, we have got to consider the rate of change of the volume as it goes. And it makes the problem 100 times more difficult. So it's easier mathematically to look at it like we started over, and this time we're going to take 100 milliliters and dump 30 milliliters straight in, and they're going to mix simultaneously in one instant, and I'm going to be right at equilibrium. Practically, that's not what's happening, but it's the easiest way to look at it. So now I need to ask myself, with my NaOH, 30 milliliters is going to give me how many moles? Well, again, two ways I could think of it. One, 30 is double 15, so I'm going to get twice as many moles as I did here. Again, that'd probably be the easiest way. Or you can just go ahead and do the math and say to yourself, 0.0300 liters times 0.50 moles per liter, and that's going to give us a value of 0.015 moles of the OH ion. Well, again, going back to that easy way to think about it, pH is going to equal the negative log, or pKa, of 4.5 times 10 to the minus fourth, plus the log of the conjugate acid, or excuse me, the conjugate base over the acid. Well, if I add 0.015 moles of OH ion, back to my picture here, however much OH I add, it's going to make that much NO2. So I know if I add 0.015 moles of a strong base, I'm going to make exactly that much of my conjugate base. So this is going to be a 0.015. Well, I also know that every time I made a conjugate base, I had to get rid of a conjugate acid, because the acid, or excuse me, I had to get rid of an acid because the acid makes its conjugate base. So it's going to be this value minus 0.015 for my number of moles of acid down here in the bottom of my equation, and that would be 0.035. And now I've got a problem I can easily solve. pH is going to equal 2.98, and I've got a new point to add where I've got 30 milliliters as my X value and 2.9 as my Y value. We're getting to be a better buffer. We're not still quite 50-50, but it's getting closer. It's getting more to the point where we're going to start to see less and less change as we go. If you're happy with this, go ahead and stop the video now and try to do, well, the next one's a little unique because it's the midpoint, but try to do problem F, G, and H the same way, and you'll save yourself a ton of time. I'm going to switch pages. It's going to be the exact same problem, just clear out everything we did. And we're going to use those values we just calculated last time, but we're going to go through, I'm going to actually leave myself some space. OH plus HNO2 is going to make NO2 minus plus H2O. And I just calculated on the other page so we can use those same calculations. Well, one, we've already calculated that this is 0.050 moles. And I just calculated on that other page. If you want to go back and look, rewind the video and see how we got that. But we just calculated that we had 0.015 moles of OH ion. We don't have any of him yet because, again, we're pretending that we're starting each of these over. Here's our initial. Then we're going to go through a change, and that OH, since he's strong, he's going to completely react. 0.015 minus 0.015 and plus 0.015. So I'm going to end up with, at equilibrium, 0 OHs, 0.035 moles of him and 0.015 moles of this guy. Conjugate acid, conjugate base. I'm ready to do my Henderson-Hasselbalch equation. pH equals the negative log of 4.5 times 10 to the minus 4th plus the log of my conjugate base, 0.015, over my acid, 0.035. And again, ending of the picture, I have the exact same thing I had over here. And I did my ice table. And if you have to do that, you really are doing the ice table over here. You're just doing it in your head. You're seeing that there's a complete pattern to it, and you're figuring it out without actually writing it down. I know some of you are going to not want to do that, and some of you are going to really appreciate being able to do that. Your choice.